Hello everyone, welcome back to the channel. Today's video is another episode of Recreation series where we try to replicate popular effects from various shows, games and anime. In today's video, we will be replicating Obito Uchiha's so broken Mangekyo ability, Kamui. The final effect will look something like this. And before we dive into the topic, a shout out to Eduardo for video suggestion, and if you're watching this, sorry it took me a while and you're breathtaking. Okay, for this I will be using Godot 4.1 and a visual shader add-on, Shader-Lib, which I will link in the description. With that out of the way, time to roll the intro. Let's break down the effect. First, we will create a quad in front of our object. Then we will project what's behind onto the quad. Then we will add some texture for dramatic effect. Then we will distort our quad's UV. Finally, we will scale our quad and object simultaneously. Okay, now let's create a quad in our scene. So, add child, mesh instance 3D. Select new quad mesh. I will call the node Kamui. Now let's create a visual shader. I will call it Kamui shader. In the flags, make sure to check unshaded. We don't want it to interact with lights. Let's also create a new shader material. I will call it Kamui, and I like to keep the extension .material. Let's assign our shader to our material and assign our material to our quad. In our visual shader, first we want to project what is behind on the quad itself. So create a texture 2D node. Select screen. It will give us the screen texture. Then take its color and feed it into the albedo. Now we want to distort the UVs, so let's create a twirl node. It is the node from the add-on, which will give us this nice effect. Now if I just set the strength to 0 and feed the output in our screen textures UVs, notice that the quad no longer properly projects what's behind. The reason is, twirl node uses the mesh UVs by default. So we need to do a lot of maths here to convert local UVs to world space, then world space to screen space, and then finally calculate the screen space UVs. Just kidding, we will simply grab the screen UVs and feed it into twirl node's UV. Now we will feed the strength from the inspector, so let's create a float parameter, call it twirl strength, and give a default value of like 200. Now we want to animate the effect, so let's create another float parameter, call it twirl progress, set the hint to range from 0 to 1 and give default value of 0. Then we will multiply these two together and feed it into the strength. We need to calculate the center via code, so for now let's create a vector2 parameter, call it twirl center, give default value of 0.5, 0.5 and feed it into the center. Now notice that our quad will have hard edges when we will distort our UVs. So let's create a UV function node with function mode panning. It will give us UVs which we can offset using this offset. Set it to -0.5, -0.5. Then take its output and feed it into vector length node. It will give us the length of a vector. Then take its output and feed it into 1- node. 1- as the name suggests, subtract whatever value we feed in from 1. In our case, it will invert the white color to black and black to white. Now let's create a smooth step node. Set the edge 0 to 0.5, edge 1 to 0.8 and feed our 1 minus output in x. Smooth step node will return 0 if the value of x is less than edge 0, returns 1 if the value of x is greater than edge 1, and for values that lies between edge 0 and edge 1, it will return the result of Hermite interpolation, which will be between 0 and 1. Then we will take its output and feed it into the alpha. And we no longer have hard edges. Pretty cool! Now let's add the texture on top. For that, let's create UV polar coordinates node. Polar coordinates are circular coordinates where x goes outward and y goes around. Let's split its output using vector2 decompose node. We want y values, so take its output and feed it into triangle wave node. It is another nice node from the add-on which will return triangular waves with values between -1 and 1. In polar coordinates, set repeat to 10. It will give us this nice triangle waves with 10 teeth. Well, actually it is 20 because other 10 are negative values, so we can't see them in the preview. We don't want them, so let's clamp this using clamp node. We will clamp the values between 0 and 0.7 because I want the texture to be a bit transparent. Then take its output and feed it into power node. Power node will darken the values which are less than 1 as we increase the power. Set the power to 10. Now let's shear our waves a bit, and for that, let's create radial shear node. Another nice node from the add-on which will provide the warping effect on UVs. Take its output and feed it into polar coordinates UV. Let's also rotate our waves, and for that, let's create a rotate node. Another node from the add-on which will rotate the UVs. We will rotate UVs over time, so let's grab the time and feed it into rotation. Then take rotate node's output and feed it into the radial shears UV. Finally, let's distort our waves a bit, so create a simple noise node. This node is also from the add-on, which will give us nice value noise. Alternatively, we can use texture 2D with noise textures as well. We will mix simple noise with our polar coordinates, so let's create a mix node for vector2. Mix node basically interpolates input A and B based on weight. Feed polar coordinates into A, noise into B. Now it doesn't matter what we feed into X for weight, but for Y feed 0.5. Take our mix node's output and feed it into vector decompose node. Now we will add this distorted waves on top of our screen texture. Then take our addition and feed it into the albedo. That's it for our fragment processor. It will look like this. Now let's head over to vertex processor. Create get billboard matrix node. Keep billboard type enable. Check keep scale. Take its output and feed it into model view matrix. We have made our Kamui into billboard, so it doesn't matter from which angle we look at it. It will always face toward the camera. For Unity folks, I have a video on billboard shader if you want to follow along. And that's it for our shader. Now we want to define the behavior for our effect. Let's say we want to create a quad when I click on any object, and then make the object disappear along with the effect. And for that, we need to create scripts. First, let's create a script called Kamui, which extends from node 3D. For now, I will just define a class name. Then let's assign it to our Kamui node. Shocker! Then let's save our Kamui node as an instance scene, or let's say as a prefab. So right click, save branch as scene, and I will save it as kamui.tscn. We will instantiate it during runtime, so let's delete it from our scene. Now let's say we want to Kamui sphere when we click on it, so let's create an area 3D node. I will call it Kamuiable sphere, then add collision shape 3D as a child, and give new box shape 3D. This is so that we can click on object. Then for visuals, let's add mesh instance 3D as child of our Kamuiable sphere. Set the mesh as sphere. Let's create another script. I will call it Kamuiable, which extends from node 3D, and assign it to our Kamuiable sphere. In our script, I like to define the class name. First, we want to detect mouse click on our sphere, so let's define an input action first. So in project settings, go to input map, let's add new action. I will call it mouse left. Then define the input, hit this plus button. In mouse buttons, select left mouse button. Now area 3D has two signals, mouse entered and mouse exited. Let's connect them to our custom methods. Select Kamuiable sphere. Let's call our method on mouse entered and connect. Same thing for mouse exited. We will call the method on mouse exited. In our script, we have these nice methods. Now let's define a boolean field. So var, I will call it isPointerOnNode. Then like a lunatic, I will define the type boolean in a dynamically typed language. But I have worked with statically typed languages my entire life, so it's easier for my mind to comprehend. Then let's set the value to false. In onMouseEnter method or function, we will say that okay, pointer is on the node, so isPointerOnNode true. In onMouseExited, we will do isPointerOnNode false. Then in process function, we will check if pointer is on node and if mouse left is pressed. If the condition is true, then it means we are clicking on our Kamuiable object. So let's create our Kamui effect. And create Kamui method does not exist, so let's create it. Now we want to instantiate our quad in front of our sphere. So we will get a direction from our sphere to the camera. Then we will say we want our quad some units away from our sphere, like this, in that direction. So for that, we will need reference of our camera. And let's also define the distance in our script. And we want to instantiate our Kamui, so we also need the reference of our packed scene. Now in our create Kamui method, let's find our direction. And for that, we will get our camera's global position and subtract it from our position and normalize it. Because we only care about the direction and not the distance of our camera. Now let's find a new position using the direction. So we will do effect distance into direction. Then we will add the result on our current position. Then we will instantiate Kamui with our packed scene. Now we have created the quad, but we need to add it to our scene. So get tree.root.getNode. I have main as my scene's main parent. Then add child Kamui. Now we have added the quad in our scene. Let's set its position as the new position that we have calculated. Now we will have nice effect if our object will be in the center of the screen, but if not, it will have some weird effect. So we need to calculate the 12 center. We will use our sphere's position as the center. So in our script, let's create a method, calculate center, which returns vector 2. Now we are using screen UV, so we will need screen position of our sphere. And our camera has a nice method, onProject position, which will do the heavy lifting. Now we have screen position, but we need screen UV of that position. So to find that, we will simply divide screen width from our X and screen height from our Y. Let's grab the screen size. Get viewport dot size. Then let's find the center by dividing our screen positions X with screen width and screen position Y with screen height. Then we will return the center. Pretty cool. Now let's go to our Kamui script. Here we want to first scale our quad from 0 to target scale, so let's define that first. And we will get the effect scale from our Kamui sphere. Then we want to smoothly scale our quad, so let's create scaling function. Here let's create a tween. Then we will tween the method. We will call it update scale from 0 to 1. And let's also define duration for our animation. Then let's pass scale in duration. Then let's set the transition type. Now let's define our update scale method. We will calculate the scale with the new float value from the tween, and we will apply that scale to our quad. Now we want to do the same thing for our 12 progress, so let's define another method called animate progress. We will create another tween to update the progress, so let's first define the duration, then create a tween method. We will call it update progress. We want to update the progress from 0 to 1 in this duration, and let's set the transition type. Let's define update progress method, and to pass the value to the shader, we need reference of our material, so let's create a shader material field. Grab the reference of our material on ready function. Then in the update progress, let's pass the value to our 12 progress parameter. Now here I also want to scale out our quad and our sphere, so let's just invert the value and pass it to update scale. Now to update the sphere scale, we will need a reference to our sphere as well as the original scale of our sphere, so let's define fields for that. We will grab these from our Kamui script, so let's create a method which we will call from that script to grab this value. We also want to pass the 12 center, so let's also create a method for that. In update progress, let's also scale out our Kamui sphere. Then when our twirl animation finishes, we want to delete both our quad and the sphere as well. So let's create a method. I will call it onAnimationDone and delete the nodes with QFree. Let's connect onAnimationDone method to our progress tween's finished signal. So when the tween finishes, call this method. Lastly, we want to call our animateProgress method when our scale tween finishes. So in scaleIn method, let's connect that. Finally, let's head back to Kamui script. For our effect scale, let's define a field. In createKamui method, let's pass that scale. We will also call setKamuiColor. Let's also set the center by calling setCenter method. And we will get the center from our calculateCenter method. And finally, we will call scaleIn method. In the Kamui sphere, let's assign these values. And it seems like I made a typo, so let me just grab the method name and call it here. And we have our effect. One final thing, if we set up multiple Kamui and create multiple effects at the same time, everything goes haywire. The reason is, right now our code is updating the same material for all Kamui quads. To fix this, we will just go to our material and check this local to scene. It will create a new instance of our material for all quads, which we will load to our scene, and now everything works. Now with this, we can Kamui cube. Kamui sphere. Kamui capsule. Kamui head of Godot statue. Nah, it would be too disturbing for YouTube. And that's pretty much the video. If you find the video helpful, consider like, share and subscribe. Wishlist Cosmic Roads on Steam. If you have any questions, post them in the comments. That's it from me, and I will see you guys in the next one.